Hi, today we want to talk about factorization. Factorization is a powerful tool in algebra that enables us to simplify expressions or solve equations and understand the structure of mathematical relationships. Now, on its own, factorization can do no good, but when used correctly and in the correct situations, it can help us to simplify problems. For example, given 2x plus 10, a method of factorization called the greatest common factor, where we take out the greatest common factor from the terms that we have, can be used as such. If we take out 2 from 2x, we're left with x. If we take out 2 from 10, we're left with 5. You should learn how to factorize by learning how to divide by the greatest common factor. So here we took 2x, divided it by 2, and the remainder was x, which we wrote. And same thing with the 10. 10 divided by 2 gave us 5. Therefore, when we take this 2 and multiply it back in, we should have the original algebraic expression that we were given. But in this case, notice it's just one step, and this one step did nothing to reduce the complexity of our question. So in this case, it is not necessary for us to factorize, but let's visualize another situation. Let us say that underneath here we had a x plus 5. Therefore, in this case, if we do the same thing, take out 2 as our common factor, then we'll be left with x plus 5. And at the bottom we have x plus 5. And we can cancel these two, leaving us with an answer of 2. In this scenario, we used factorization of the greatest common factor to simplify an expression successfully. Now, there are other methods of factorization that we can discuss, namely the difference of two squares and trinomials, difference of two cubes, perfect squares. All of these are common factorization techniques that we employ in order to improve our simplifying abilities in maths. So the next one we want to talk about is the difference of two squares. This is the law, and this is how we apply it. We have two squares, one number and the other number, and in order to simplify this expression that you may be given, you open up two brackets and you find the square root of a and the square root of b, and then you put those in the brackets, and then you just swap the signs. One will have a plus b, one has a minus b. So in this step, we want to simplify this equation, or rather this expression, using the method of difference of two squares. So we're going to take 16 minus x squared, and that's going to give us the square root of 16 would be 4. The square root of x squared is x. So we add, then we subtract, like that. And then we say this is all over 8 plus x. And in this case, as you can see, it does nothing for us. There is nothing that we can do to simplify this problem any further. So what we can do is we can again try and change the problem. So I'm just trying to show you that in some instances it is pointless to employ any techniques to factorize, because once you have factorized, you should be able to then cut off or simplify your expression a little bit better. So what we can change here is the 4. If I put a 4 inside here, then I will have a 4 plus x. Then we have a 4 plus x at the bottom, a 4 plus x at the top. Those two cancel, and then we are left with 4 minus x, like that. And then this is difference of two squares. So it's important that you learn how to identify these cues and you learn how to apply them properly. Now, moving on to trinomials, we have this problem over here. Now, this problem is already in the format that I would have preferred it in, but I want to show you what it would look like a step before this. So this is something that you would likely get in a test, or you could see this in your NBTs. So if we multiply the top, so let's keep the top the same, 2x squared minus 32 all over, and now we're going to multiply this, 8x plus 3x, that's going to give us 11x, and then x times x, that's x squared, 8 times 3, that's 24, like that. So let me rewrite it like that, multiplied by x plus 3 over 2. So now when you get a question like this, it may seem intimidating, very much so. But if it is something that you're used to, you understand that what I need to do is I need to factorize this that looks like a trinomial. Let me form two brackets out of this. In fact, let me change this question, since I changed the previous question a little bit as well. So I'll change this 8 to a 4, and that will affect this, will become a 7x, and that will become a 12. So now let's imagine we are given this expression at this point, and we are asked to simplify it. What do? First off, we identify the trinomial, and then we identify the 12, because the 12 is the key to simplifying this. The constant is what we use in order to try and factorize a trinomial. And on top, let us not ignore that the top as well. We need to simplify the whole thing. So what we can do is we can factorize the top as well by taking out the greatest common factor. So taking out 2 from the top, that will leave us with x squared minus 16, like that. And then we can say this is all over, open up 2 brackets, and then put x in those brackets. What are the factors of 12 that can give us 7 when we add? Or multiply them to get the positive 12. So that would be 4 and 3. We have x plus 4, we have x plus 3. So you see, we've gone back to the equation that I had written earlier. But now what we can do is we can use the algebraic skills that we already have to simplify this. Since everything is multiplying each other here, we can cancel the 2 with the 2. We can cancel the x plus 3 with the x plus 3. Then what we are left with is x squared minus 16 all over x plus 4, of which x squared minus 16 is something that we can simplify by factorization using difference of 2 squares. We open up 2 brackets, put x inside. One we're going to put plus 4, one we're going to put minus 4, and this is all over x plus 4. Again, we are able to cancel because everything is multiplying each other. And we have at the bottom x minus 4 as our simplified answer. So these are techniques that we can use in order to simplify equations or expressions. In this example, we just used it to simplify expressions, but you can extrapolate this into equations as well, but we will discuss that in the videos to come.